Hey, what's up everyone? Welcome to this new chapter of my training course to learn SwiftUI when you already have experience with UIKit. For this third chapter, we are going to focus on the topic of state management. This means we're going to talk about all the property wrappers that are very iconic of SwiftUI. I'm thinking of add state, add binding, add published, all these little annotations that you are sure to see somewhere whenever you are reading a SwiftUI tutorial. And we will even talk a bit about architecture because we'll talk about MVVM. We're going to introduce a view model at some point in this chapter. As always, you have in the description the link to get the code. If you are following live, I recommend you check it out now because in the project, you will find the finished project, but it will contain the boilerplate code I will copy paste along with JSON file with some starting data, and you will need it when we get to that part. What else do I want to say before we start? Yes, of course. If you are watching live, remember that you have the chat to ask me any questions that you could have. And never forget that any question that you ask, I will answer it, and it will be super useful for people watching the replay because there's a very good chance that if you had this question, the people watching the replay will have the same question. So by asking the question, not only do you get an answer, but you also give a hand to people watching the replay. Finally, if you're watching on YouTube, this course is available for free, but as you can see on the corner of the video, I've set up a page on Buy Me a Coffee where you can leave a tip if you've enjoyed the course. So the link is on the video. It's also available on the description. And if you leave a tip during the live, your name should even be displayed on my video feed. And I think it's all I wanted to say. Yes, one last thing. If you would rather download all the videos rather than watch them on YouTube, you also have a link for that in the description. I think I've said all I wanted to say for the intro, so let's get started with this chapter about state management. So like in many tutorials, I'm going to use the classical example to show how to implement state management in a framework. We're going to make a to-do list. This choice is not the most inspired, but there is a good reason why a lot of tutorials use the to-do list as their example. It's because it's simple enough that anyone can understand it easily. It can be set up quite quickly, and it usually covers all of the typical use cases you need to deal with basic state management. So let's get started. Let's create a project. So we create an iOS app. I'm gonna call it state management. Make sure it's SwiftUI for the interface language. All right, going to put it on my desktop. Okay, so we have our project, going to close that inspector. I'm gonna close the preview because we are not going to do view code just for the beginning, because we are going to begin by actually defining our data model. So the data model is actually not going to depend on SwiftUI at all. It's just going to be some regular Swift struct. So I'm going to create a new Swift file. I'm going to call it to-do item. And inside this file, I'm going to define a struct. I call it to-do item, like that. And inside this struct, I will need to define a few properties. So let's see. What do we need? We're gonna need an ID, because I think I might have already shown you that whenever we want to display some kind of list in SwiftUI, we need a way for SwiftUI to tell the elements apart. So we have an ID which will be a UUID. This ID will never change, so I'm declaring it as a let constant. And then we need what will actually be displayed on the UI. So I'm going to introduce a first var, so a first mutable property. It will be a title, so the title of the to-do item, like do this thing or do that thing. Then I also want to be able to deal with a description for the to-do item, but that one might or might not be there. and this way we will see how we deal with optional values in a data model when we want to display them in a view. And finally, the essence maybe of a to-do item is to be able to switch from the state to do to the state done, and we're going to represent this with a boolean. No need to introduce an enum here because we only have two cases we want to deal with, to be done and done. So it's going to be a boolean with a default value of false. Let me check my script to make sure I told you everything that I wanted. Okay, so we have our data model. Then after that, we can implement the view that will display one to-do item. So for that, I'm creating this time a SwiftUI view, no longer a Swift file, and I will call it to-do item row. Row is kind of hard to say in English. To-do item row. Why am I calling it to-do item row and not, for instance, to-do item cell like we would be used to in UIKit? The reason is that for horizontal items in visual collections, SwiftUI uses the term row, so I'm going to use it, even though there is a very good chance I will say to-do item cell at some point because force of habits. But when you're doing SwiftUI, it's better, it's more idiomatic to call it a row rather than a cell, but it's the same logic. So I create my to-do item row. Okay, so let's see, let's implement it. So first thing will be, I will show you the preview, and we're going to notice that the preview by default is the entire iPhone, but it's way too big for a row. I mean, if we were to implement the row, it's going to take all the available space to it. I mean, it will have access to all the available space to it, and it's not just a good way, it's just not a good way to preview it because it's not realistic. What's good is that there is a way to solve this issue. It's because we have control over the size of the preview. To control it, we can call the modifier preview layout right here, and we can give it a preview layout. So there are several possibilities. It could be size that fits by saying just take the size that you need. Here I'm going to give it a fixed size. It will reflect the size that the row will have in the list displayed on an iPhone, and so it will be a width of 300 and a height of 70. Let's see, did my preview update or not? Okay, the preview was paused. So normally, my preview is supposed to look differently, and it doesn't for some reason, maybe because there has been some changes. Oh, it's because I was in the live preview. Okay. And in the old Xcode, in the previous version of Xcode, by default, that preview was the one you would have. Okay, so now I have the size I have asked, and let me make it, yes, so that there is no weird zoom. Okay, so we have a preview that is realistic. We can start implementing the to-do item row. So let's see. First, we will need to have, I guess, our to-do item. Let's see. Yes, we need to have our to-do item. So I'm going to create this item like that. So to-do item. For now, it's a constant because I'm not dealing with the fact that we're going to modify it. Let's see. I have a missing argument here. So, of course, I need to provide a to-do item in my preview. So when you need to provide some piece of data in your preview and you don't yet have a way to decode it from a file like we will do later, there is a nice trick that you can do, and it's to create a static constant. So static let like that. I'm gonna call it to-do item without description. Okay, and inside I put a to-do item Let me try and put it in a way where it kind of looks nice. Maybe like that. Let's see. Okay. So for the UID, I just create one. And for the title, let's say we want to buy some bread. And let's put an emoji here. This way it will look nicer. And so here we have the to-do item without description, and now we can use it inside the preview. And everything should build again. Okay. So now let's actually display this to-do item. We won't deal with the button to go from undone to done. We will keep it for later. We'll start by displaying the text. So if you have some memories of what we did in the last 2 chapters, this should be fairly easy. So first I want my text that displays the title. So like that. I'm going to give it a style with the modifier font and say it's going to be a headline. All right, that's pretty nice. Then I would like to display the description if there is one. So first I'm going to create another to-do item, this time with a description. So I'm going to also update a bit the text so that we can differentiate the two of them. So it will be buy some milk, for instance. Let me get the emoji and let me add this time a description like get a lactose-free one because I'm lactose intolerant. Okay, and then we can show, so we would like to show a second preview. So what we can do is group the 2 previews together like that. I'm going to leave the modifier preview layout at the level of the group. We'll see if it works. And so I show the second one like that. Okay, so factoring the modifier out worked. And now you can see we have our 2 different previews. And I think we can even give them name if I do. Yes, preview display name. So here we can say without, yes, you can even see the name being updated live here. So without description, and here with description. And this is so useful when you start to get, like, for instance, when you have a component that can have several states, it can be so useful to be able to just get a look at all of the possible states. Okay. So now we have a way to provide to-do item with a description. We just need to actually display the description. So we have more than one item to display. If you remember what we saw in the chapter about the layout system, you should already have figured out what I'm going to use. I'm going to use a VStack. So I embed inside a VStack. I'm going to add a second text modifier. This one will display the description. But you can see I get an error because the text here expects a string and not an optional string. So there are several ways to deal with it. For instance, we could provide a default value. You can see that it works. But I want to show you another way of doing it, which is that we can do an if-let inside the body of a view. So we can say if-let description equal item dot description. Then, now that we have the description that is non-optional, let's use it. It's kind of the same idea, except that we don't always display a text with a default value. We display a text when there is something to display. So it's 2 different ways to deal with potentially non-existent view. I wanted to show you the 2 alternatives. So like that. Then I'm going to add a font, and this one will be a sub-headline. Let me take a look at the chat. So I have a question from Jonathan who is saying, what do you think about adding preview code to the main code in terms of can it add noise when visualizing? That's a good question. I guess this modifier right here, for instance, I guess I could have moved it here. Yes, I could have moved it here. But even though it's possible, personally, I've never done it, and I would rather keep the thing that is for the preview in the preview for a simple reason, which is that even though SwiftUI is arguably simpler than UIKit, the bodies of views can still get complicated, complex, quite fast, and the less stuff you have, the better. Plus, since this code is only used in preview and not in production code, having it in production code can only create like issues. So a lot of downsides, no real upside. So I would keep it inside the previews. If you know an example where it actually makes sense to put part of that code in the actual SwiftUI code, so in the non-preview code, I would be super curious. There might be one, but I have nothing that jumps to mind right now. So we are showing the title and subtitle. This is kind of nice, but I guess we can do better, because usually when you have a to-do list, you tend to not center things, but display everything from the left. You would have on the left the button that we will add later, and then the title and the subtitle. So to do this, we are going to put our VStack into an H stack, so to stack items horizontally. And what we want is to say, let's put the items, the title and the description as much to the left as possible. And last week we saw the one SwiftUI view that allows you to do that. So maybe you remember which one it is. It's the one called Spacer, which will take as much space as is available. Then we want to refine a bit the design. For instance, add a bit of padding on the leading edge of the VStack. That's better. And also the alignment centered on the VStack is not the best. So let's update it to make it also a leading alignment. So like that. And of course, our toggle button to go from done to undone and undone to done will be at the left of this view right here. But for now, it seems to be pretty nice. I think we can put some extra padding here on the H tag so that it has room to breathe once it will be in a list. And then we can give a fixed height to the row, because the row will be displayed in a list. The width of the list will depending on the device. Typically, it would be like larger on an iPad than on an iPhone, but it kind of makes sense to give a fixed height, because we know which items there are and we know which kind of height we want them to take. So I'm going to give it a fixed height of 70. It's kind of a simplification, because in reality, maybe we would like the height to grow as the number of lines in the description, for instance, grows. It could be a realistic use case, but I'm going for the simpler approach, because I want to focus on state management and not on advanced layout techniques. Eduardo is saying, is there an alternative to spacers to align views? There is an alternative to spacer, which I covered in the last chapter. Let me show it real quick. So the alternative here to spacer would be to say, okay, the VStack has a frame with a max width that is infinity. This way, the VStack takes all the space available to it, so all the space of the row minus the padding right here. And then inside that frame, I want my content to be aligned on the leading edge. And you can see that normally, if I toggle between this and that, I think, yeah, we have the exact same result. And so using the modifier frame with a max width set to infinity is kind of an alternative to using a spacer. And same thing for a max height set to infinity when you're in the case of something being laid out vertically. I see a few other questions or remarks. So some dev is saying, may I have some more information on creating multiple static properties within previews in terms of usage and benefits? So these properties, it's basically just to have like some data that is already available to use in your previews. So it's just like mock data. It's for mock data. I would say like don't put like dozens and dozens of items that way. But when you need some mock data and you want to put a bit of structure in your preview, it's a nice way of doing it. And Will, you're saying SwiftUI calculates intrinsic content size. Is it more common to use fixed sizes in SwiftUI? So SwiftUI does compute intrinsic content size. You know what? At some point later, if I forget, remind me, but I will try to remove this modifier and we'll see if it makes a difference and what kind of difference it makes. Okay. I'm going back with the spacer just because it's the version I have in the finished version, and this way, like, maybe it will avoid like me getting into some weird bug that I don't understand immediately. All right, let me see. Okay. Okay, so we are pretty good because right now we are displaying our to-do item. But of course, displaying it is not enough because in an actual to-do list app, we want to be able to modify the title and the description. We are going to need to have a way to write them, basically. So let's see. Do I want to make a way to write them here? Yeah, I guess we could do that. So I could turn the text. I'm just looking in the finished app. I didn't put text fields, so I'm wondering actually why. So I'm launching the simulator with the finished app just to see. Okay. Okay, so I had simplified things and okay, so I only add text. All right, I will stick with what I had like made, and it's maybe because I'm going to cover it a bit later. Okay, let me check. Actually, I did things in a different order. That's why I'm struggling a bit. Okay, so we did that part. Okay. Okay. You know what? Before we do like the nice button, I'm just going to put a first button so that we have something that that is easier to follow. So I'm gonna put a very simple button. I'm just going to call it button, and in the action, what it will do. So first, let's see. Yes, the button is displayed. After that, we'll make it like much more beautiful. But for now, I just want to have the button that will update the state of something in the to-do item, because this is what will introduce the whole reasoning for how to deal with state management. Because now that I have my button, I need to set an action to it. And what I want to do is item.isDone.toggle. That is the logical thing to do. However, it doesn't work because it says you cannot use a mutating method on a let constant. That makes total sense, and Xcode suggests that I change it from a let to a var. So like that. Okay? Then we get another error which is much more interesting. Cannot use mutating member on immutable value. Self is immutable. So what this means is that when you are in the body of your view, you are in a computed property of your struct. And there is a rule in Swift that inside a complete property of your struct, self is immutable because it just makes, or maybe because you're in a closure that is computed inside a method of a struct, and in that place, self is immutable because if it were to be mutable, it would create just too many weird situations. So how can we solve this issue? That's when the property wrappers introduced by SwiftUI come into play. So what we want to say, the meaning we want to share with SwiftUI is that we want to say when the item changes, the view needs to be redrawn. To say it differently, the view, the body of our view, depends on the item and needs to be updated as the item is updated. You probably have an idea of which modifier we should use for that, and I think we've used it in a previous chapter just to see how it worked, and it's the @state modifier. You can see that just by using this modifier, the error has gone away, which seems a bit weird in a way, but let's see why, and we can see why by jumping to the definition of @state. So @state is a property wrapper, so an annotation that you apply on a property. What's interesting is that I want to show you here, it's wrapped value. So what you get when you access a property that is annotated with @state. You can see that there is a getter on that wrap value, there is a setter, but that setter has a very interesting characteristic, a characteristic that feels a bit weird because it's a non-mutating setter. It feels weird because by definition, a setter is supposed to be mutating. And the way to explain it is that you can kind of see @state as a box that contains a value. And so when you change, when you set a new value in that box, the value inside the box changes, but the box itself doesn't change. This is what this non-mutating self reflects. To give an equivalent, it's like you have a struct, you create a class that holds a value of that struct. If you update the value in the instance of the class, the value will change, but the instance of the class will have stayed the same. And this is the same logic that leads to this non-mutating set. And it's actually quite important because it's the fact that we have this non-mutating set that allows the whole updating a property of a struct inside a closure defined in the body of that same struct that makes it work, even though in Swift it shouldn't really work. It works because we have this @state that will be in between and it will be able to intercept the change, let the SwiftUI engine know about it, and also keep that box that is constant so that Swift is also happy with how things have been implemented. But actually, @state is not the property wrapper we want here. And let me explain why. The reason is that @state means that the view owns the data. The view is the source of truth for the data. However, it's probably not going to be the case here because we won't be using our to-do item row in isolation. We will use it inside a list, and so it's much more likely that the list view will own an array of data, an array of to-do item, and then it will simply lend a to-do item to each of the rows in the list. So we want a way to say this to-do item row doesn't own the item, but it possesses a way to get the value of the item and to set a new value for the item. And if you've seen the previous chapter, this might ring a bell because we saw a type that was exactly the combination of a getter and a setter, and that type is binding. So binding is a type, but it is also a property wrapper. So we can use @binding, and by saying @binding, we are saying this to-do item row will operate with some data of type to-do item. It will be able to read from this data. It will be able to write to this data. the view will update when new data is written. However, to-do item row will not own to-do item. To-do item will be owned by its parent view or one of its parent view, one of its ancestor view that will pass a binding to that piece of data. And so by using binding, we get basically the same feature that we would have gotten with addState, because we are still able to update the data in the view. We're still able to use it. The only difference is that now with addBinding, we say that to-do item row doesn't own the data, but it operates on it, and the data will be provided by its parent view or one of its ancestor view that owns the data. Okay, so to-do item row is pretty good. However, we have a problem here because we are passing a to-do item, whereas now to-do item row expects a binding on to-do item. So how could we solve this? There are several approaches possible, but the most simple one is to use a constant method, a static method on binding, which is called constant, and it returns a constant binding to something. So you can kind of see it as a binding whose getter would always return what you've passed as an argument and whose setter does nothing. So I'm going to also wrap the second argument in this constant like that. Okay, so now it's working again. So of course, if I were to click on the button, it wouldn't do anything because it's a constant binding, but our code builds now. And so, for instance, if we want to make sure that, that the isDone property changes, we can do a few things. First, we can actually make the view have a different UI when isDone is true and when isDone is false. We can, for instance, when a to-do item is done, strike through the text, both the title and the description. This is actually quite easy to do in SwiftUI. You do the strike through modifier, so like that. It has an isActive argument. Let me show it to you. This isActive here, which is a Boolean. So I can do item.isDone. So when the item is done, it will be struck through. So like that. And we can already test the static behavior of this. So if, for instance, for the first one, let's see, I put isDone to true. You can see that indeed it works. However, if I remove this and I try to interact with my preview, so I go to the live preview, you can see that nothing happens. This makes total sense, and the reason is that we are providing a constant binding for now. So constant bindings, they are nice in a preview, but they are kind of limited in their functionalities. Fortunately, it's quite easy to provide a stateful binding, so a binding that will encapsulate some state. But before I show you, I want to show you an approach that you might be thinking of, but that doesn't work. Because you might be thinking, for instance, okay, well, I need something that is an addState to store the data. So why don't I do something like this? So addState static var, I call it my to-do item, like that. I pass in a to-do item, okay, something like that. So I give it a UUID. It's going to be another task, something like this. And let's see. I mean, since this is a to-do item, I can create a to-do item row. And from this addState here, maybe I can pass a binding. Let's see. This code builds. Okay, this code builds. Let me resume the preview and let's see what happens. Okay, so this code builds, everything is displayed correctly. But if I click on the button, you can see that nothing happens. And the reason is that even though using @state here in the preview, it builds correctly, it's not going to have any effect because @state will only reflect new changes and will only update the UI when there is a change to the property when it is used inside a view. So I wanted to show that to you because it can be like the natural way of thinking. Okay, we have this @state property. Why don't we also use it on the preview? It actually doesn't work in the preview. But we can still build on that ID because to have a binding that works, we need to have a state that is available somewhere. So how about we create a view whose entire purpose is just to store some state that we can then use inside our preview. So let me just put the code back to how it was before I did my little experiment. All right, let's do it like that. I'm going to hide the preview for now, and I'm going to create a new Swift file. So I'm gonna call it stateful preview wrapper. I'm going to copy and paste the code, so it's in the project that's available in the Xcode project, so either on the GitHub or on the project that was next to the video. It looks like this. You can see it's a generic type over two generic arguments, a value, which will be the content of the binding, and then a content, which is a view, so the view we actually want to display. And this stateful preview wrapper is just a view, but it's a view that is a bit like special in its use case because it holds an instance of the value with an @state property. And then in its body, it just calls the content and provides it a binding to the value. And you can see that the content is a closure that takes a binding to the value and returns some view. So the role of this view is not to display anything. It's not a view that will display anything on the UI. It's a view that has for entire purpose to just store a value in an @state and make it accessible through a binding. So it's a nice little trick to be able to use a binding with a state that actually changes and actually drives the UI from your preview. And now that we have this, we can update the preview. So here for the to-do item row. And what we can do, for instance, so let me see where we could use it. Let's use it for the one with a description, for instance. So here I'm going to use my stateful view preview wrapper. So I need to provide a value. So I can give it as an initial value my static property right here. So it will be the initial value of what will be stored inside the @state property that the stateful preview wrapper wraps. And then inside the closure, so I have the binding on the to-do item, and I can create my to-do item row. I pass it this binding. So let me put the display name right here. Okay. Let me display the preview again. And so now, normally, let's see. No, because it's the second one. It's the one with the description where I've used stateful preview wrapper. Now it works. We can see that when I click on the button, the binding has been updated. And so when the binding was updated, the value stored in the @state property changed and the UI was also updated in consequence. So what did we see with this first example? We saw the property wrapper binding, which is very similar to @state because it allows us to store some data that we will update. And when this data changes, we want the UI to be updated. To say it differently, we store some data that drives the UI. However, the difference between binding and state is that state implies ownership of the data, whereas binding only implies that the view uses the data but doesn't own it. So the logic you would see, the hierarchy you would see, is that at the top level, you will have a view that owns the data. It will then pass a binding to the child view that only needs to use the data. That child view itself could pass the view to another child view, like we will do later when we implement the nice little button. And so at the top level, at the parent level, we have an at state for the source of truth for the data. And then from that at state, a binding is derived, and the binding can be passed to the child view, which can itself pass it to a child view and to other child views. And what's nice with this mechanism is that even though it is quite simple, it is also quite powerful, because by using at state and at binding, we are able to implement two-way data flow, so between a parent view and a child view. And this data flow is done through the init, meaning that the data has to be carried manually across all views. I'm saying that because later we will see another mechanism that allows you to do a data flow in a way where you don't have to explicitly carry the data across the views. Also, I want to emphasize the way that at state and at binding allow us to have a data flow that is two ways, meaning that the parent view can pass data to the child view, and the child view can update this data and have an impact on the parent view. The reason why I'm emphasizing it is because there are also cases where you don't need this two-way data flow. There are cases where you simply want a child view to display some data with no way of modifying it. And in that case, it's not useful to put a binding in place. You can just pass the data, and that will be more than enough. And actually, we have this example right under our eyes. The text view, for instance, the text is only displaying some text. It's not a text field. And so the text doesn't take a binding to some string. It just takes some string. However, a text field would take a binding to a string because a text field would need a way to update the data. And I want to emphasize this because it can be kind of like an easy pitfall to use a binding everywhere by default, even though there are situations where you actually don't need to have a binding, and when you don't need one, just don't provide one, because it leaves less room for bugs and for mistakes. Let's see. I see a few comments. So Joao, you're saying, so this stateful preview struct, it's a file we should keep for the future. Yeah, it can definitely be like super useful. It's a really nice little helper, and it's pretty cool. And Omar, you're saying that means if I want to inject the view with my model, I should go with the wrapper. So this stateful preview wrapper, it's only for the preview. We will talk later on how to deal with dependency injection, but this stateful wrapper, it's only for the preview. Please do not use it in actual production code. Okay, let me see. I want to see if we've covered everything. No, I think we are pretty good. For the to-do item row. Now the next step is to actually implement the list itself. So let's go back to my views. I'm going to do it in my content view, so the view that was created by default by Xcode. And let's see, where do I want to start? Okay, first we want to have some data, because we want our list to be realistic. So this is when we will use some of the assets that are in the Xcode project. First, we're going to have a JSON file. So I'm going to try and do a command drag and see if it works. Copy items if needed. Yes, it worked. So we have this JSON file, which has just like the two items I had in my preview, but inside the JSON file to make it like more convenient. And then we're going to also add a Swift file to easily load this. So let me also add this file. So it's called array plus load, and it's just a static method on arrays whose elements are decodable to be able to decode them from a JSON. So it just uses decodable under the hood. It's purely a convenience method that we're going to use. Of course, to use it, we need to update our to-do item, and we need to update it to make it codable. So like that. Perfect. And now I guess I can start to implement my list in my content view right here. So let me show the preview. All right. Okay. So first thing, we want to store the array of to-do items that we're going to display. So this time we will use @state because in this example, I want the content view to own the array of data. So it's going to look like this. So to-do items. Okay, it's gonna be an array of to-do item. And to get the initial value, this is when I use my method from JSON, and so it will be from the JSON named to-do items. So like that. Let me see if I can. Okay. Seems the code fits the screen. Okay, let's see. Does it build or not? The code can throw, but errors. Oh yes, because the code can throw. So what we can do is I'm going to ignore the errors, and if there is an error, just return an empty array. It's not the best code you could write. Let's see, why doesn't it work? I guess it's because I need to do something like that. Okay, this time it's happy. So it's a bit of a shortcut, but it's a way to have data that is easily available to us in order to build the list and interact with it in a way that is kind of realistic. Now time to implement the list. So let me remove everything from the body. So we are using the list here. The list, you can see, has a lot of potential initializers. I'm going to go with the simplest one, where you pass in as a first argument the collection you iterate on, and as a second argument the closure that you will use to generate each view that will constitute the list. So here the list iterates over the array of items, and the closure will be called each time with a new to-do item as its argument. We can see an error that says initializer, so init, requires that to-do item conforms to identifiable. So remember, I think we had seen this in the first video, the basics of SwiftUI list, just like all of the views that iterate over collections, they need a way to compare views, we could say. And they don't do it through equatable, they do it through another protocol called identifiable, which requires to have an ID. So there are two possible ways to deal with it. Either you can explicitly provide a key path to the ID. Here it would be the property ID of my to-do item, and this would work. We are manually providing the property to use as the ID, but there is another way to deal with it, and it's to make the struct conform to the protocol identifiable. I think we already took a look at this protocol, but let's do it again because it's very simple. There is an asserted type ID that must be hashable, and there must be a complete property that you can get, which is of type ID. In the case of my to-do item, this requirement is already satisfied. That's why I can just say I implement the protocol and not need to change anything else inside the implementation. So now I can go back to my content view. You can see I can build and it works. Okay, now it's time to actually display the rows inside the list, and this will be easy because we have implemented the to-do item row. But you can notice one thing, which is that here I have a to-do item, and here I expect a binding. So the question is, how do we get this binding to a to-do item? To even like reformulate the problem, here we have an array of items in an add-state property. How do we get from this add-state array an array of bindings? You see, how do we distribute the binding over the array? And as it turns out, there is a very nice syntax for this, which was introduced with iOS 14, if I remember it correctly, and which is you can put a $sign in front of the array to say I want a binding on the array. And once you've done that, you can also put a $sign on the argument in the closure. And when you do that, you say, okay, in the closure, I want to get a binding to each item inside the array. And now we can just pass the to-do item. So we get a build that failed because I made a mistake somewhere, because you also need to use a $sign at this point. And this way, by using this syntax of putting, so we've seen putting the $sign in front of a property annotated with @state or @binding to get a binding, but we hadn't seen that one, which is to put a $sign in front of the argument of a closure. And it's a very nice syntax, because if you didn't have this in iOS 13, you needed to like manually deal with indexes in the array. It was super confusing and super error prone, whereas this syntax is much safer. And as you can see, it works. We do have our list that displays our collection of items, and there are only two items in our collection because the array is quite small, but that's already a good start. Let's see what I want to show you after that. The next step is to actually implement a better version of this button is done. So let's go for it. We are going to implement it, and it will be the opportunity to see a bit more code on how to deal with shapes in SwiftUI, because we haven't dealt with shapes a lot. I showed you a bit code that use like circles, rectangles, but we haven't used it a lot. So let's get to it. So I'm creating a SwiftUI view. I will call it to-do toggle button, because it will allow a Boolean to go from false to true and from true to false. Okay, so let's create it. So first, before I start implementing the view, let's wonder on what kind of state does this button need. It's going to be a toggle button, so it will make a Boolean go from true to false. So it only makes sense that it needs to store a state, or at least to manage a state. But the question is, should this property be an @state or not? If you've been following what I've explained since the beginning of this chapter, you might have a feeling that @state is not the best choice here. And indeed, @state is not the best choice here, because there's virtually no scenario in which the button will own the Boolean value. The button is just a way to interact with this value, but it's pretty clear that something else will own this value. Just like with a text field, something else will own the text. So to reflect this in our SwiftUI code, we declare the Boolean with a binding, which means that the button will have a way to read the state to update it. When it updated, the UI will be also updated. However, toggle button doesn't own that state. That state, it borrows it from a parent view. I see a comment. So Joao, you're saying we could even use something like to-do item row $0 if we drop the to-do item inside the closure. Indeed, I guess you could do it. Honestly, let me go back to it. In that case, I would kind of recommend, so let's see, you're saying we could just use like the anonymous argument, so like that. We get a build failed. We get a build failed. Let me show the, is there, damn it, it's because, okay, I'm going to just like Okay, so the build succeeds. The build succeeds, so that's a very good remark, that just by saying that it works. However, I would still be in favor of explicitly writing this, because you are drawing attention to the fact that, hey, I'm getting a binding and I'm passing a binding. When you use the other syntax, it's less obvious. There is still something to see it, because there is this $sign right here, but it's a bit less obvious. And honestly, in most cases, I would rather go with this syntax, because the fact that you're passing a binding is kind of important, because a binding can update data. So the more visible it is, the better it is, I would say. Even though in the end it's kind of a matter of preferences. But I would say, except for like very short syntaxes, I would rather stay with it, especially because this syntax might not be known by everyone. Also, that's something to keep in mind. Okay, let's get back to it. So we have our binding here. So if we want to test our button in a way that is meaningful, we will need a way to have this binding available in the preview. So remember what we use. We use our magical stateful preview wrapper. This time the default value, the initial value, will be false. And inside the preview wrapper, we just move the to-do toggle button like that, and we give it the state as an argument. Okay. Now it should build successfully. I can resume the preview. Perfect. And now let's actually draw this button. So we're going to start by the inactive state of the button. And I want it to be a circle with nothing inside. So I'm going for a design that is kind of similar to to the reminder app in iOS. So let's see how I can do that. I can use a circle, which is a SwiftUI shape, and on it I can use the modifier stroke with a line width to say I want to only have the stroke of the shape, meaning its border, so something like that. And then say I want to have a foreground color of blue, so like this. Okay, so this is the inactive state of my button. For the preview, it's a bit big, so I'm going to give it a preview layout that is kind of more realistic to how it would be used inside my app. So as a like 40 by 40 button, that's pretty nice. You can notice that I didn't put a padding on the button, and it's kind of on purpose in a way, because there is the question, once you've put a padding, it's I don't want to say impossible, but at least it's not super easy to remove it. So it begs the question, whose responsibility should it be to set the padding? Should it be the button, or should it be the view that uses it? Here, when I see it, it feels that like when there is no padding, the button is going to feel really weird. So I guess it kind of makes sense to set the padding inside the view itself. Of course, the padding was a bit too much. Let's see, could I have like a smaller padding like that? A padding of 8 maybe? Okay, that seems more realistic. So I have my circle for when the button is in the state not done. Now when it's in the state done, what I want is to draw a little circle that is filled inside. So first, I'm going to make the preview a little bit bigger, because I'm noticing that it might not be the best to follow. Yeah, that's already a bit better. And so here I have my circle, and I want to have a discus inside of it. And to do that, so I want to put one shape on top of the other. So maybe you remember what kind of view to use. Actually, if you're watching the replay, now might be a good time to make a little pause and try to remember it. We saw it in the previous chapter about the layout system. We are going to use a Z-stack, which allows us to put items on top of each other. And so I'm going to move the padding at the level of the Z-stack. So I have the circle in the Z-stack, and it will be always there because I want it to be displayed regardless of state is set to true or to false. But for what is inside of the for what is inside the circle, it will only be visible when the state is set to true. So I'm going to update the value right here so that we can see it while I type it. So like that. And I'm going to have a second circle, except that this time I want it to have still my foreground color of blue, but I want it, so here it already looks kind of nice. You know what? I will do the improvement later, but right now it already looks kind of nice. You can see that when I go from false to true, I have indeed two different states. The preview didn't refresh. Let's see, false is good, but for true, it should be a bit different, but sometimes the preview is a bit annoying, yeah. Yeah, it didn't refresh. Okay, I just need one thing, is the actual button that will make it so that when I click, when I tap, it's going to go from false to true and from true to false. To do that, it's actually fairly easy. We just need to use SwiftUI's built-in button, which is basically a view with a gesture recognizer. There is a bit more into it because there is some logic about when you release your tap, but conceptually it's kind of the same thing. And so I'm going to use the init of button that takes an action and a label. Be careful in SwiftUI, when SwiftUI says label as a closure, it means any kind of view. It's not just a text like you might think when you see the word label, which can be a bit confusing. So for the action, that's pretty simple. We do state.toggle. We are allowed to call a mutating method on state because we have a binding to it. And for the label, we just take the Z-stack and cut and paste it inside of it. Let's see, does it build? It builds. If I go back to a default value of false, and I resume my preview, you can see that when I type, it goes from one to the other. It's not perfect. We can see some weird flashing. There might be a few reasons for it. First, when I change my state here, I want to make sure that everything is going to be animated. And for that, you can use with animation, which is a function that takes a closure and makes sure that every data that is changed inside that closure will update the UI in a way that is animated. So let's see, did it make a difference? Yes, you can see now the animation is looks much better. There is just a weird there is just a bit of a weird thing. I'm looking at the finished project to see if there is the same weird behavior. There is this same weird behavior. It might be a bug of the preview. Let's see. We will see a bit later how it goes. Before we keep on moving, I just want to refine a bit the design, because what I wanted was not to cover the entire button with this filled circle, but rather leave some white space between the border and the filled circle. And to do that, we need to introduce a new view that we haven't used yet, because what I want to say is, let me write it, will become much more clear. I want to say that the width of the circle should be 80% of the width of the parent view. Now, how do I get the width of the parent view? This is where the modifier I want to introduce comes into play. So this modifier is called a geometry reader. We already saw a scroll view reader, and it's kind of the same idea in the sense that we can embed a view inside a geometry reader. This geometry reader gives us access to an object that is called a geometry proxy. So it's better to name it proxy. And this geometry proxy contains information regarding the current geometry. For instance, if I want to set a width for my second circle on my proxy, I can access the size. So it's the size that is available to this view, to the label of the button. And so I can take the width of it and take only 80% of it. Let me resume. And I'm checking that, okay. Now I get the design I wanted. The only thing I'm trying to understand is why the view displays from the top of the screen, even though it doesn't in the other version that I have right under my eyes, trying to see if there is a difference. Oh yes, it's because it's kind of an interesting one. It's because right now the geometry reader is a filling view, which is going to try and take as much space available to it. And what I'm going to do is that on my button, I will call a modifier that's called scaled to fit. And scale to fit is going to say, okay, you only take up the space that you need in a way, or rather, it means you take as much space as possible, but by preserving your aspect ratio. And by doing that, the button will no longer take all of the extra white space it doesn't need. Without it, it would take all of the space available, so the entire screen, and then would only occupy the top of the screen because the circle, it's a circle, and by default, it doesn't like compress to another shape like an oval, for instance. But it's important to understand that here, the geometry reader would take the entire screen. I'm trying to see, like, can we see it? I'm going to remove this. Yes, so here we can see, let me de-zoom like that. Okay, you can see that the geometry reader takes all the space available to it, and then inside it, the circle takes as much space as it can, as much as its equation allows it to take, because it still must maintain its aspect ratio. And it draws from the top, because geometry reader is one of these views that draw from the top, just like scroll view, which is not the standard behavior in SwiftUI, but these views, they behave like that because they have a bit of a different behavior from the rest. And when I use the modifier scaled to fit, you can see that now the view will still take as much space as it needs, but it will fit to what it needs, meaning that it will no longer occupy space, that it will just leave empty. And so the view is now displayed from the center because the geometry reader only takes the space that it needs. Zhao, you're saying, can you explain again the geometry reader, the idea behind these proxy topics that exist in other components? So let me explain it again. The idea is that we need somewhere in our view to access the size that is available for the view to draw itself. So we need a way to access this. The thing is, we cannot access it by accessing like a property of something. Like we cannot do just like, okay, let's put the circle inside the variable, let's return the circle at the end, and in the, I haven't written it correctly, circle, yes, like that. And then do something here like circle dot frame dot size dot width. That's how you would do in an imperative framework like UIKit. It's not possible in SwiftUI because SwiftUI doesn't work like that. The body in SwiftUI is a pure function, so you cannot just like set some variables and then get some data to it, modify them. And the way you do in SwiftUI when you want to get some information about your environment, there are several ways to do it, but one of the ways that SwiftUI uses is to actually embed your view in a parent view that will provide you the information you need through an argument. So we saw it when we wanted to interact with a scroll view. To interact with the scroll view, we would put the scroll view in a scroll view reader, and the scroll view reader would pass as an argument to its closure a scroll view proxy that would allow us to interact with the scroll view. And here it's kind of the same logic to interact with the space that is available to the view, so to the Z-stack. We embed it in a geometry reader, and the geometry reader will provide us through its closure argument with a proxy, and that proxy gives us the information of what's the space that's available to our view as we are defining it. Yes, you can see the proxy as like an element of context. It's kind of like a context. It's a way to interact with something that is outside the scope of you defining your view. It's kind of hard to phrase it correctly because in a way it's a very like generic concept. But it's basically when you want to access something that is like outside your scope. Like for instance here, you want to access the size that was proposed by the parent view. You embed the view in something that will be able to capture that information and make it available to you through its closure argument. Okay, cool. I'm glad to see that that explanation was helpful to you. Okay, so we have our button. Now it's time to actually use it. So let me see. There are things that I wanted to show you with the stateful preview wrapper, but I already did it ahead of time. We saw geometry reader. Perfect. All right. So now what's left is to use the to-do toggle button inside our to-do item row. So if you remember, I had put this button as a placeholder, but we're going to be able to remove it and instead use the to-do item, it's called to-do toggle button like that. It takes a state as an argument, so a binding to, it takes, for its state argument, it takes a binding to a Boolean. How do I get a binding to a Boolean? Here, the property I want to update is the isDone property of my item. And to get a binding from it, I prefix it with $. You can see that it worked. And so that's what I told you earlier. From an state property, you can derive a binding. And then from a binding, you can derive another binding either to the item or to the value itself or to one of its sub-properties like I did right here. So I'm going to update the UI a bit because it doesn't, it could look better, I think. Let me see. So here I have the button. Okay, yeah, now the leading padding is actually, it was not the best, but now it looks kind of nice. And if I go to a live preview, when I tap on the button, you can see that. So the text is being crossed out. What's weird is that the button is doing something super weird. It's moving a bit. What could be the reason for it? It's interesting. I'm trying to see if in my finished project I have the same bug. Let me see. I'm not using a stateful. I'm not using a stateful wrapper. Let me use it real quick. So stateful preview wrapper, like that. Item. Okay. Okay, so I don't have the bug in the finished version. That's interesting. It means that something is wrong somewhere in the code. So let's try and spot it. So you're using background color to check for the cause. That's a good strategy. I'm trying to see. So here the button takes this space. Okay, the VStack is here. I have the spacer that is just after. And I'm gonna look at the code of the to-do toggle button and just compare it with the version that I know seems to work. So geometry reader, this tag, a circle, okay, if state. Okay, that seems pretty good. It's funny, the only difference here, I have added this padding. So let me just get rid of it. That's the only difference I see. Could it be this padding? So it's so weird. The difference was the padding. I have no idea why it gave such a difference. You see, like when, oh yes, let me show you something cool. You see this, so I'm back to my to-do item row. You see this little like pin icon. When you enable it, then you can switch to another file, and normally it keeps the previews from that you have pinned available. This way, like we can still see here. So it's this one. So we can see that when the padding is there, there is the issue, and when the padding isn't there, there is no issue. What's fascinating is that I'm trying to find like an explanation for it, but I have nothing that jumps to mind. It's so weird. Oh, I think I know why. I think it's because of the padding. Because I've put the padding, and because there is not that much space available, there is not enough space for the view to draw itself like it would like to. And so it's kind of like if a constant had broken. I'm going to see if I put a padding of 4. Yeah, you see with a padding of 4, there is no issue, but you can see that there isn't enough space. Like there isn't enough. I think I understand why. It's probably because since I have a thickness of 2 for the line, there must be a size after which, when it's smaller than that size, the 80% of the size doesn't like compensate, doesn't leave enough room to show a difference between the border and the filled circle. So this is this padding modifier that does the issue. I had added it and it wasn't in the finished project. Now I understand why, and so now it's back to working again. Awesome. And if I go back to my to-do item row, perfect, we can see that it works. And you can see also that as I tap on the button, the text gets stricken through, I guess. And you can see that this is being animated. And the reason is because I use with animation in the closure of my button. If I remove this with animation, then the animation is no longer there. So it might be something that you want to have the animation or not. I wanted to show you how it's done. And I think in a later chapter, I will show you how animations work in more details. Okay, so let's see. So a few people have tried to help me find the bug. Thank you. Jerry, you're saying you need to go. Don't worry, the replay will be available at the same URL. How long will be the live? I guess between 2 hours, 2 hours and a half, something like that. I don't want it to be too long, but it is an important topic, so I will try not to rush it. Okay, let's see where we are. All right, let's go back to the list actually. So I'm going to remove all of this. I'm going to go back to my content view, so to my list. Okay, so my list is working pretty well, but I still want to do this thing, to do a few more things. Okay. I want to add a new business rule, we could say, which is that I would like that when I set an element to done, so when I tap on its button, I would like for it to go to the bottom of the list. Basically, I would like the list to be ordered with the not done elements first and then the done elements, kind of like I think Reminder does it, and then Reminder like removes the elements. But for instance, if you do like a checklist in the Notes app, it asks you, do you want to have automatic ordering? And if you do select it, then you have this behavior. So let me just check how I want to implement this. Yeah, this is when we're going to start talking about like a view model. So there are two ways that we could implement this behavior of sorting whenever something, whenever an item has been updated and its state went from done to undone and from undone to done. The first solution would be to somehow like catch the event and move the element in the array. I'm sure there is a way to do it, but we're not going to do it because it's way too complex and there is a much better solution, which is to actually have on the one hand the array that contains the unsorted data and then dynamically compute a sorted array that the view will display. And what's interesting with this example is that it will lead us to kind of naturally introducing a view model and having a business logic in the view model that is complex enough that the example feels realistic. So this is when we introduce a view model. Let's see why we want to have a view model. The reason is that if we don't have the view model, we could say, okay, we want to have an ordered to-do items, which is going to be a compute property, like that. It will somehow like do a sort. So if I do like to-do items dot sort sorted by, I don't want to implement the sort right now, but here there would be like the sort, and I'm just going to return an empty array so that it builds, but we would do the sort here. If we went through that strategy, so not introducing a view model, when we try to use here our ordered to-do items, we would have a problem, which is that to-do item row expects a binding, but our ordered to-do items array is computed dynamically. It's not the source of truth for the data, and so you cannot get a binding from it. So with this approach that seemed the most simple, which was just let's introduce a new compute property on the view, we would actually need to introduce some like kind of complex logic to get a binding from the original array using the element of the ordered array. It's possible to do it, but it brings a lot of complexity, a lot of room for mistake without adding anything. That's why we won't go this way. And rather, we will do the more like sensible thing, which is to have a nice app architecture. And so we're going to introduce a view model that will manage the array for us, and that will also manage which version of the array should be presented by the UI. So which sort should be applied to the array before it is presented on the UI. So first thing, to have this view model, I'm going to hide the preview for now. We're going to create our view model. It's going to be just a Swift file. I'm going to call it content view model. Actually, I'm realizing that the name content view is not the best because it's the default name, but it doesn't reflect on what I'm trying to do. So I'm going to rename it. I'm going to rename content view to do item the list, like that. And content view model, I will rename it to do items list view model. It will be much better like that. Okay, so this view model will be a class because it will be an object that will have like a life cycle of its own, calling it to do item list view model, like that. So interestingly, we can notice that in SwiftUI, views have become struct, whereas they were classes in UIKit. And on the kind of other ways, data tends to become classes in SwiftUI. The reason is that views are recreated on the fly. They are just struct. But if you need to have some logic that is kind of like persistent across the view being updated, then you need to introduce a class for it, because you need to have an instance that will keep living as long as your view is displayed on the UI. That's why my view model is going to be a class. And it's going to be a class that implements a particular protocol called observable object. I don't know if I need to, no, I don't need to implement to import SwiftUI for that, but I want to show you what is inside observable object. It's a type alias, so I want to go to that one. So it's a protocol that can only be implemented by classes, and it has only one requirement, which is to have an object will change publisher, to which you can send an event, which is of type void. I will show you like how it works just after. And basically, this object will change is a way for the observable object, for the class that implements observable object, to notify an observer, that observer will be SwiftUI, that its value has changed, and so that the view needs to be recomputed. So this is how observable object works under the hood. Let me get back to my view model. Okay. Now I'm going to start moving data between the view and the view model. Here I'm realizing that I should have called this actually to do item list view, because this is much more, it describes the situation much better. Okay. So I want to move my array of data first. So I'm going to cut it from my view and paste it inside my view model. Remember earlier in this chapter, I told you that add state only works inside views. So here it's telling me it's unknown. That's because it's part of SwiftUI. But if I imported SwiftUI, the file would build correctly. There is an error in the view, but we will deal with it later. The file would build correctly, but add state wouldn't do anything, because we've seen it, add state only has an effect on updating the view when you use it inside the view. So you don't want to use add state here. what you would want to do is to build on this object will change that we have seen. So we would like to do something that is kind of like having a will set property observer that would say, okay, whenever a new value will be set to the property, I want to notify by calling send on my object will change publisher. This is conceptually what we would like to do. It's interesting to write it out like this because it shows how the content of observable object is actually used. And when it's written like that, it's very clear that whenever a new value is set to this property, then object will change gets a new event which notifies SwiftUI that the view needs to be recomputed because the content of the view model has changed. Fortunately, we don't need to write this by hand because there is already something there that encapsulates this feature. And the thing that encapsulates this feature is the property wrapper at published. So at published, you only use it inside an observable object, and its effect is that when a value is set on the property that at published annotates, it will send an event to the object will change publisher, and it will let whatever SwiftUI view is using the view model be aware that the state of the view model has changed, and so the view needs to be recomputed and potentially updated. Don't forget two things. First, you don't need to use at published with all the properties of a view model. If there are some properties that when they change, the view isn't supposed to be updated, it's totally fine to not use at published with them. However, if you forget to put at published on a view that should drive the UI, then your UI won't be updated, and the reason is that you've forgotten to use at published on your view. And it's actually a mistake that is like easier to make than you think. It happened to me like a couple months ago, like spent close to like half an hour trying to understand why the view wouldn't update. The reason was that I had forgotten to add at published to the property of my view model. I'm seeing a few comments. You're saying, I didn't start from UIKit, just from SwiftUI and tried Combine. I like the way you explain as all iOS devs. It's good to know that, thank you for your comment, because it's good to know that this training course also has values for people who don't have a strong experience with UIKit. I gave the name Learning SwiftUI when you already know UIKit because it was a nice way to like, to differentiate and to make it more appealing to experienced UI dev, but it's good to know that it's also accessible if you are not like super experienced with UIKit. Okay, what will be the next step? The next step will be to actually move this code right here. I'm going to move it away inside a method I will call load items like that. So this method will be able to call here the method from JSON. So I will do self.toDoItems equal try and decode from the JSON. And if there is an error this time, I will deal with it not in the best way ever because I'm doing a fatal error, but at least the error would be returned to the console. Keep in mind that in a real app, you wouldn't do things like that. Here, I'm just having like some static data so that we can easily have some data available without having to set something more complex like core data, for instance. Okay, so now I can give a simpler default value, which will be the empty array. All right. And then what do I want to do? I guess I should put the view back to work. I'm just making sure. Yes, that's the next step. So I have a simple version of my view model for now. Now let's go back to the view. So let's go back to my ToDoItems list view. So I need to replace the addState property that used to contain the array. So I need to have basically my view model. So I'm going to instantiate it. I called it to-do item list view model. But I cannot just have it like that. I need a way to tell to SwiftUI, that this is a view model that should make the UI redraw when it changes. And here it can get a bit confusing because there are two different property wrappers that you can use. There is first @observed object, but there is also @state object. This can be confusing when you don't know the difference between the two of them. What's kind of nice is that it's the same logic than between state and binding. @state object is the same thing than @state. It means that list view owns the view model. It owns it in the sense that it will keep the reference around as long as the view is present in the view hierarchy. On the other hand, @observed object is similar to binding in the sense that it says that to-do items list view uses the view model but doesn't own it, and so there is someone else that is responsible of keeping a strong reference to the view model. Initially, in the very first version of SwiftUI, if I remember it correctly, you would only have observed object, and then people noticed that there were some weird behavior where the view model would be recreated from scratch, even though that's not what you wanted. And so they introduced @state object, which enforces this ownership relationship between the view and the view model. So here we definitely want to use @state object. And the reason is that our view owns the view model just like before the view owned the array. And just like you're saying, state object is like state. Exactly. So now that we have the view model, we just need to use it. So here we can no longer access directly the to-do items. We need to do viewModel.toDoItems. The good thing is that to get a binding, we can keep prefixing viewModel with the $sign. It's one of the nice features that @stateObject brings. So let's see. Now the build succeeds, but if I run the app in the preview, you should see that we will have something that is not just like before. You can see that the list is empty. It's absolutely normal because remember, I've moved the code that initializes the array inside a method that I need to call. And I want to show you how you call a method to get your view model started. You use the modifier onAppear on your view and you do viewModel.loadItems like that. Now it's back to working like it was before. Why did I make that change? There's actually a very good reason why I made that change, and it's because, remember, I told you in the first chapter that your view hierarchy is created like ahead of time. If we take a look at our view, at the top level of our view, we have to-do item list view, which is created, and all of the views we could have, like in a tab bar, for instance, would be created. And as soon as to-do items list view is created, then so is the view model. And so if I still had in the default value the decoding of the array from the JSON would happen straight from the launch of the app, even though the view itself might not be shown straight from the beginning. And so the bottom line here is that I think I might have already told you that you want to keep the init of a SwiftUI view as simple as possible and as less computation intensive as possible, because that init will be called most of the time, can be called ahead of when the view will actually be displayed. It can actually be called when the view will never be displayed. So you don't want to do anything that is costly inside the init of a SwiftUI view, like making a network call, like starting some background work, like decoding data from a JSON. But that also holds true from the init of a view model that would be created when the view is created. And that also extends to the default values of the @publish properties, because this default value is part of the init. It's just a Sugar syntax, so that I don't have to define an init explicitly. And so that's why I moved the code that was costly into this load item method. It forces me to remember to call the method in onAppear, but it comes with a great advantage performance-wise. So I really recommend that you follow this approach. You're saying if observable object publish something, the view gets rebuilt. Absolutely. To be even more precise, if observable object emits a change, the body gets recomputed, and then the new body gets compared with the previous one to see which part of the view actually needs to be redrawn. It could be that maybe no part of the body has changed, because maybe the property that changed in the view model is not used by anything in the body of the view. So you have the right logic. Just wanted to point out that there is this intermediary step between updating the UI, which is to compare the new body with the previous body. Okay, let's see. So we've optimized. Perfect. I see a few comments, so let me answer them. When I use MVVM, I try to make the methods as events happening, not as the view comments the view model. That's interesting. Could you share an example of how that would work? But that's indeed like that could be also like a strategy of having a way to send events to the view model. You're saying onAppear can be called multiple times. That's true. It can be called. So onAppear, it's the equivalent of view will appear. I think we saw it in the previous chapter. And so indeed, if you want to only do the loading once, then you would need to add maybe some extra logic inside the view model, if that makes sense, because maybe you actually want to like refresh the data also. But for instance, you could do something like guard to do items is different from the empty array, else just return. And this way, when there is already some data, you're not attempting to reload. Yeah, it's better if I do like is empty equal false, something like that. So that's a way that you could deal with it. But that's a very good remark, that onAppear can be called more than once. It really depends on what you actually want to implement. Okay. Okay, so to have a method like onAppear inside the view model, which can be also like a nice solution, because definitely like what you don't want to have is to need to call several methods on the view model, because that's just like super error prone. So having methods in the view model that mirror the life cycle of the SwiftUI view kind of makes a lot of sense. So I think now it's time we implement the actual sorting. Let me see. First, I want to make sure of one thing, which is that it doesn't work anymore, because I guess I might have done something wrong inside my my guard statement. I'm pretty sure I've done something wrong in the guard statement. They are so easy to get wrong. So I'm saying I want to continue. I want to-do item is empty to be false. No, it's the other way around, yes. It's if it's empty, then let's try to fill it with some local data. So I got it completely wrong, and now it should be better. Okay, now it's better, it's working. I just need a way to animate the sorting. Okay. So let's see how we could do it. I had put an interesting approach. Yes. So let's try it this way. I'm trying a different way than what I have in my solution. What we could do is that we could make it so that the view model does have the published property to do items. However, there is another property that will be displayed to do items. It will also be an array of to do item, except that it will be computed. It will be computed dynamically. So for that, I would do to do items dot sort by, and so in the closure, I get this condition, which is a bit weird because you need to wrap your head around it, but to sort the not done items first, and then the done, it's this condition right here. Okay. Because this is actually not going to work, but I want to explain why it's not going to work. Okay, so we have this, and now we could say we want the list to actually display these displayed to-do items. But it's not gonna work because we actually still have the same problem than before, which is that we cannot get a binding from these display to-do items because it's not an @published property. It's just something that is computed dynamically. I don't want to deal with getting like the index in the original array, even though that could be doable. I want to show you another approach, which is to get an event, to get the event that something has been modified, that the item has been modified in order to update the array. So what I will do is that I will introduce a new method that I call reorder inside my view model, and I will move this code right here to it. And instead of sorted by, I'm doing sort by, so that I modify the array instead of returning a new sorted array. And then I need a way inside my view. So let's put back the view like it was. Let's see, it should be working now. Why is it not working? So I have to do items here. Okay, I have my method reorder. I have an error. What is this error? It says, let me get a little bit more screen real estate. Okay, no, build succeeded. It was like just the cache in Xcode. Okay, so it's back to working, and I want to be able to catch the fact that this item has been changed to update something inside my view model. And a way that we could do it is to rely on the fact that since this property is published, we should be able to get a publisher from it. However, if we do it like that, yes, I'm trying to show you like all the ways that that don't work because there is an issue. Like for instance, we could be thinking, okay, on my to-do items, I can actually get a publisher to it. So it looks like that. And we could say, okay, whenever there has been a change to my to-do items, I want to reorder it. The issue is that when you reorder the array, you actually trigger a new change to the array, and so it would trigger like basically like an infinite recursion, and you would get a Stack Overflow. So what we want is not catch the fact that the array was changed, but rather than an element in the array was updated. And for that, I want to show you a little trick that I had come up with. And this trick is to have a binding in which we can intercept the fact that a new value was set to the binding. So I'm going to show you the code and it will become much more clear. So I'm creating a new file which I call binding plus extension. I want to import SwiftUI because binding is in SwiftUI. And I'm going to make an extension on binding. And so I want to define a method in this extension that I can call on the binding to pass a closure that will be called whenever the binding has been updated, and then return the binding so that I can still use the binding. So kind of like a modifier on a view, but I want to have a modifier on a binding. Just like we have onAppear modifier on a view, I want to have on new value modifier on my binding. So let's actually implement it. So on new value, I take a closure which will be my handler. And if you have a solution, I will be very curious that you share it also in the chat to see how you would do it. So I'm going to introduce this modifier, binding of value. So like that. And I return a new binding that will, for the getter, just return the wrap value, because the getter, there is nothing to do. And for the setter, what it will do is that it will update the wrap value, and then it will also call the handler, or rather, I will rename it in side effect, because the goal is to implement a side effect that should be triggered when a new value has been set to the binding. And with this nice little extension, if I go back to my view, on the binding that I pass to my to-do item row, I can use my modifier on new value to say, okay, when there is a new value set to the binding, but the binding only refers to the element in the array and not the array itself, then on my view model, I want to reorder. And this way, when an item of the array is updated, we reorder the entire array, but it will not trigger an infinite like a chain reaction, because we react to an item of the array being changed and not the array itself. Let me check if I have implemented everything I need. Let's see what happens. Yep, we do get the behavior that I wanted, which is that when I set an item to done, it gets like pushed to the bottom. So the not done items are first in the array, and then the done items come after. So if you want to share your solution, I'm super curious to see what approach you would have taken, because I'm pretty sure that there is more than one approach for this problem. But what's interesting is that when I try to do it, the initial ideas I had, they each like came with issues of their own. Like when I wanted to do like a computed array, then it was hard to get the binding. It was doable, but it was not the most ergonomic. When using the publisher, it would trigger a chain reaction. And so you're saying, for the items list view, I use item list model like you, except I do not do binding in list. And then in item view, you put item observable to, and item view has observable object. Oh, so you're saying that you make the item an observable object. If I get it correctly, you make the struct I had made into a class. Is that it? So it's indeed it's indeed a good solution. I would say if you work on a complex if you work on a complex app where you will need to like implement this logic at scale, your approach is probably the best because it scales. It's going to scale very well. But if you are on a more like a simpler context, I get this approach of doing like intercepting the change to the binding can be a nice way to keep things simple. But I would definitely be cautious about it for the simple reason that this is kind of hacky in the sense that it's not something that SwiftUI exposes by default, even though it was quite easy to build, and so you might not want to like use it too much because I am not convinced that it scales as much as the other solution. But I still wanted to show it because I feel like it's a nice little solution that can save like kind of a lot of time when you need to solve like a simple problem. And it also showed like allowed me to show you how like all of the easy intuition that we could have actually don't work with this problem of we need to reorder the array of items when the user updates one of the item. Let me see what I had for you. We're getting close to the end of this chapter. I just want to add a bit more interaction, be able to delete an element and to move some elements in the list. So first, how to implement a swipe to delete on that list. It can be a bit tricky actually, because if you look on the list and you type delete, you will see nothing about it, and there is a good reason for it. Why there is no onDelete modifier on the list. Before I do, just want to display this comment so that it's available on the replay. So yeah, a lot of trial and error before you get it to work and you don't feel like it's elegant. I think what you say, especially at the end, is a good point. I don't think that there is like, at least like, I don't know of an elegant solution to solve the problem I'm showing you in SwiftUI just by using the native like SwiftUI tools. And when I tried to solve it, I was kind of surprised that I was struggling that much to find a solution because the problem is actually not that complex. But it's always interesting to see that there are like simple use cases in which like SwiftUI doesn't have like a simple solution out of the box. So back to the question of why there is no modifier onDelete on the list. It's because this modifier does exist, but it exists somewhere else. And for that, we're going to have to split our list into two. Because right now, our list actually, it's responsible of doing two things. It's responsible of iterating over the array of items. So like we see here, but also to add a presentation layer on top of it. We can see like the rounded corners, the dividers. These are things that list adds. And actually, this syntax where we directly pass in a collection to list is kind of a sugar syntax to keep things a bit more simple, but this can be fully separated into two different views. So we can turn the list into a for each, which we have seen before, which is a way to iterate over a collection. Now, by itself, a for each doesn't come with any with anything about how the views should be laid out. So we still need to embed the for each inside a list to have this like this logic of how the view should be laid out. It seems I have like, yes, there will be no closure. I mean, there will be a closure, but with no argument. Are we good? No, it seems like I'm missing a bit of indentation. Okay, this time I think we should be good. All right, we have an interesting bug that I will address just after. But first, I want to point out the fact that now we have the for each that just does the job of iterating over my collection and creating a view for each item in the collection. And then we have the list that is responsible for laying out these views that were created by the for each. We get no data displayed. That's normal because my modifier on appear is still on the for each, and since to do item is empty by default, for each is never displays anything, and so that's why I need to move the on appear to the list so that it actually gets called. Now it actually gets called. So it's just the same code than before, except that we have pulled the list into two parts. The part that is about UI layout and formatting the views, which is here, and the part which is about creating the views from the collection. And it is on this for each, on this part that is solely responsible for iterating on the collection, that we have the modifier on delete. I see a few questions. So let me see. State object var view model. So you're using a state object with something that is like a shared instance. It seems you tend to do this. What's bad about it? Okay. So I guess you can have a shared instance for your view model. I guess in that way, it would be better to use observed object because your view doesn't own the view model because it's shared and it's a static property that probably that already like owns it. So using a shared instance doesn't seem like using a shared instance as a view model is not the best, but it doesn't seem something that is like completely unreasonable. But when you do so, I guess you would want to use at observed object and not at state object, because in that case the view doesn't own the state object, but rather it gets it from another place, and the place that owns the instance is the static property that is defined on the type of your view model. And we will see, like in the later chapter, how to deal with dependency injection in order to not need to store it inside, to store the view model inside a shared variable. Back to the onDelete. So we have the onDelete modifier, which takes a closure that takes as an argument an index set. So why an index set? It's because it's the indices that should be removed. It could be more than one if you put the list in edit mode and not just do a swipe to delete. So inside this method, we need to delete some items. And what we're going to do, we're going to implement inside the view model the method for that. So I'm going to implement the method delete items at index set, and I will have my index set. And what's nice is that on arrays, so on to-do items, I do have a method remove at offsets, which takes as an argument, it's off screen, so I'm going to do it like that, which takes an index set as its argument. So I can just pass in the argument like that. And if I go back to the view, I can call on my view model the method delete items at indices like that. And so now I can do my swipe to delete. Perfect. And you can notice that here I am defining a closure just to call a method with the exact same signature at as the closure. So we can go for another shorter syntax, which is to use what's called the point-free syntax. So it's a syntax where you simply pass a reference to the method like that, and you see it still works. There is no magic expected. The reason why it works is because the signature of the method is the exact signature of the closure, and so passing a closure that calls the method or just passing the method is the exact same thing. And if you wondered where the name point3 comes from, it comes from this syntax, because we pass a method rather than calling it on something. That's why it's called a point3 syntax. And so with this, we have implemented the onDelete. Let me see if there was something else I wanted to show you. I think there is one last thing I want to show you before we end. Oh yes, I want to show you also the onMove, because it can be a bit tricky. So onMove, you can see it takes a syntax, a function where you have an index set and an int. So we're going to implement the same method in the view model, and as it turns out, this signature for the arguments is similar to something that we will have in the API of array. So a method move items from index set to new index. So it's to be able to move like several items at once, so like that. And so on to-do items, we will call the method move from offsets to offset, which matches the signature that I haven't written entirely. So like that. Inside my view, I can just pass the reference to the method. So it's I think I've made a mistake. Func move items from index set. Oh yes, that should be much better. And so now inside my view, okay, view model, move items. Okay. And if I resume the preview, perfect, it's working again. All right. You might notice that there is actually no control to move the elements. That's because to do that, we need to put the list in edit mode, and I'm going to show you that, because it will force me to have a navigation view, which is perfect, because the next chapter, so next week or the week after, will be about handling navigation in SwiftUI. So let's put our list in a navigation view. Not hard, just need to embed it in a navigation view like that. Just going to update the indentation. Okay, let's see, does it still build? Yes, I'm going to resume the preview. So the preview is still good. What's interesting is that now that we are in a navigation view, we can display a navigation title. So we do it with the modifier navigation title, and why not call it today's tasks, like that. You can notice one thing is that I've called this modifier on the list, so on the child view, and it somehow had an effect on the parent view, the navigation view. The reason why I want to show you that is because it shows that the mechanism I've showed you in this chapter, which is to have data flow from between a parent view and a child view, a two-way data flow. So with like descending data and how do you say it? Uploading data? Not really, but I'm looking for the right word for it. I'm going to rephrase it. I've showed you with addState and addBinding a way to implement a two-way data flow across the views of your apps, but there was one key characteristic of this data flow is that you had to explicitly pass bindings through the inits of the child views. And here you can see we have a modifier that shows that there is somewhere in SwiftUI a different mechanism, because the modifier navigation title called on a child view is able to make this data bubble up. That's what I was looking for. Bubble up to the parent view without going through a binding. So the reason why I'm showing you that is to kind of like foreshadow a later chapter of this course, which will be about advanced data flow, and we will see that it's possible to implement data flows that are kind of implicit in the sense that they don't require passing a binding through the init of child views, and this is an example of it. That's why I wanted to show you that. But it's not the only reason why I put a navigation view. It's to be able to set its navigation item. So I never remember navigation because it used to be called navigation bar items, and they deprecated it and they renamed it to use toolbar. Okay, so we want to use toolbar. I want to have content, so it should be something like that. So I have a, I'm gonna do what I wanted to do first, the one that works. So because I want to have a trailing item on my navigation, and it says, okay, I should use toolbar with navigation bar leading. Okay, so I'm going to do toolbar, and for the content. So what I want to have is the edit button, which is something that is built into SwiftUI. And where do you do this navigation? I guess it might be an argument of toolbar. So there is this thing, content, okay, toolbar content, it's that one. So the one that returns some toolbar content, and if I do it like that, toolbar content. How do you create this thing? It's toolbar item apparently. Okay. Toolbar item, placement, and content. Okay. Thanks a lot for your help. Navigation bar trailing. So by default it was put there, but I want to show you like the full API. So like that. Okay, I'm going to give us a bit more breathing space. So before, and that allows me to address an interesting topic, which is that what I wanted to use was navigation bar items, and you can see that this has been deprecated and replaced by a new API. It's something that you will kind of see a lot because SwiftUI, as it evolves year after year, they refine the API, and basically here the logic is that before you had a dedicated modifier to put things in the navigation bar, and then they realized that it could be unified by just dealing with toolbars and be able to interpret the toolbar as a navigation bar in some situations. So you use a toolbar modifier, which is a bit more generic. You need to also write a bit more code in order to have the same feature available. What's interesting is that I want to take a look at what is the availability for this modifier. This one seems to be okay, iOS 14, for instance. So if you are doing iOS 13, you wouldn't have access to it. But remember what I've told you since the beginning of this course, you should not do SwiftUI in production in iOS 13 because there are just like too many issues and it's not kind of not worth it. What you gain, you will lose on other issues and on very frustrating bugs. So that's the new syntax. What's important is that it added the edit button, which allows us to put the list in edit mode. And so now we can do the reordering that I wanted to implement. Okay. So you were saying, yes, toolbar item, thanks for the help. I'm looking at the chat. You have to put a toolbar item in the toolbar, perfect. And so interesting use thing to use like list row inset, edge insets. Can you share like what's the logic you have in mind behind using this modifier? And on my end, before we finish, one last thing I want to show you. It's more connected to the list rather than state management itself, but it's the fact that on the list you can deal with a list style. So I think I've showed you that for a few components in SwiftUI. For the text field, for instance, we've seen that there were text field styles. Kind of the same thing. You have several like different styles for a list. So the plain one, for instance, which looks like this, which is kind of similar to the reminder app, or like the inset, or the one that I had, which I think was the grouped. So we have the grouped, which groups things, but still keeps like a different color for the background, and then the inset grouped, which is, yes, the one that I had already set. Oh, so I think your code is it like the code that when you want to add like custom buttons on the custom buttons when you slide the row, because there is a modifier that was introduced, I think with iOS 14 or 15, to do that. Oh yes, before we finish, I had forgotten at some point. I said I would like to go back and remove the frame modifier I had put here. So I'm gonna pin the preview of the list, and I'm going to remove this modifier right here to see what happens. Okay, so that's interesting, because since now I don't have like the frame for the list, the button takes a lot, really a lot of space. So of course, in that case, I want to give a frame, an explicit frame to the button. For instance, say, okay, you are like 40 by 40. So something like that. And now let's see. It's looking kind of nice. I think the button, I would like to see like the frame that it actually takes here, because it seems like it's not centered, you see. Maybe like in terms of alignment, I should say it is centered. No. What if I go here? I would really like to see like the space that each item takes. So if I remove this, so the toggle button is there. I given it like this frame, okay. You see, like here it kind of looks good, but here it feels like it's way too much, space here compared to next to it. But I think it's the same thing actually here. We have the VStack, okay, the text, the description, then the spacer. Oh, actually, the issue might just be that I had some leading padding at some point. So like that. Yeah, it kind of looks like it kind of looks nicer, and so it answers the question of, do we need to hard code a frame for this for the cell? We don't need to hard code something. The list is able to use like the intrinsic size. Then the question is like, if in your design you want to enforce the fact that each cell should have like the same height, you can also hard code it. But at least we see that without it, it works. And the reason why it works is because the text have an intrinsic size, because when you have the string and the font, you know how much space it takes to display it. The vstack has an intrinsic size because it's a combination of two texts that also have an intrinsic size. The button doesn't have an intrinsic size by itself, but as soon as we've given it a frame, I don't need that. As soon as we've given it a frame, it is like constrained to something. So there is a size defined. And finally, the hstack also has an intrinsic size because the button has a size thanks to the frame modifier, and the vstack also has a size. Okay, I see one question. SwiftUI has content hugging and compressed resistance priorities. That's a very, very good question. Let's see. If I take like this view, for instance, if I look at compressed, I don't think you will find the equivalent in modifiers, even though like I'm not 100% sure, but I would say by default, actually by default, like for the views that are like fitting views, like the text, for instance, SwiftUI is content hugging by default, because if I show you the text, if I show you the frame taken by the text, you can see that here, yes, here the text only takes the space it needs. So I would say SwiftUI views, they are content hugging by default. And then if you want them to take like more space, you can do it by using, for instance, the modifier like frame with max width or max height, like we've seen before. So I would say you don't find the same like concepts, just like in UIKit, where you would set like priorities for compression resistance and content hugging. It's there in a different way, in the sense that views like text, they will be content hugging by default, and then you can make them take more space by using the frame modifier, for instance. And views that don't have an intrinsic size, like shapes, for instance, so the button is a combination of shapes, so it doesn't have one, it will take all the space by default, but then you can make it fit a space by using the modifier frame, which is kind of similar to like setting a compression resistance that is like less important. So you can achieve the same goal, I would say, but you don't find an exact mapping of these two UIKit concepts, which kind of makes sense, because in UIKit, these concepts they come from the fact that you're dealing with constraints, and here we are not dealing with constraints, and the way views are laid out in SwiftUI is very different from the way that a system of constraints is being solved in UIKit. Okay, so it's been almost 2 hours and a half. I expected this chapter to be like a bit long. I think it's not that much longer than the previous one, so it's still like reasonable. So just like last time, before we end, I want to do a quick recap of what we've seen. So this chapter was called State Management. So my goal was to show you what were the basics mechanism in SwiftUI to deal with state, meaning to deal with data that will change as our app is used by the user. We saw that for the simplest cases, we could use @state to mark a piece of data as some state that drives a SwiftUI view. We saw that @state implies ownership of that data. It implies that the view owns the data and the view is the source of truth for that data. We saw also that when a child view needed to operate on the state of a parent view, it would do so through a binding. So the child view would say that it expects a binding, and the parent view would be able to pass a binding from its state using the $syntax. We saw that a child view could in turn pass a binding from the binding it received by also using the dollar syntax, and it could also do it by passing only a binding to a sub-properties of the state it received as its argument. I wanted at some point to highlight the fact that bindings allow for a two-way data flow. So when we want information, when we want the child view to be able to update the data, but there are lots of cases where we actually don't want or need the child view to update the data. Like here on this text only has to display a string, but it doesn't need to be able to modify it. And in that case, there is no need to bother by implementing a binding. You can just pass in the data and it will implement this one-way data flow between the parent and the child view. Then we saw that it's also possible to introduce objects that are responsible for managing state. So SwiftUI kind of naturally pushes us to using view models. So these view models implement the protocol observable object, which allow a class, an instance of a class, to let SwiftUI know that its state has changed and that the view needs to be redrawn. I mean, might need to be redrawn, but the body needs to be recomputed. We have the @published property wrapper. So here that we have right here, which is a nice way to automatically emit a change when a property gets updated. And finally, we saw that when we wanted to use an observable object in SwiftUI view, we had two choices for the property wrapper that will annotate the property holding the view model. Either @stateObject, which similarly to @state conveys the fact that that the view owns the view model, and most of the time it will translate by the fact that the view will be the one instantiating the view model. But there is also @observedObject that exists when the view is only handling the view model, and kind of similar to the relationship between @state and binding. @stateObject and @observedObject have the same relationship. So when you are a child view that is past its view model, then you should use @observedObject to annotate the property that stores it. And if your view model is managed by another part of your app, then you should also use @observedObject, as you should only use @observedObject. @stateObject is only there when your view actually owns the view model. And by owns means it's responsible for creating it and keeping it alive. Finally, one last thing we saw was that this navigation title modifier hinted us to the fact that there exist other mechanisms in SwiftUI to make data flow between child views, like the list here and navigation view, which is its parent view. That's what we will see in a later chapter that will be dedicated to what I have called advanced data flow mechanism in SwiftUI. I can name them so that if you want to look them up in advance, you can. There are two of them. There is the environment, which allows us to pass data from a parent view to a child view without explicitly passing an argument through the init. And there are the preference keys, which allow us to make data bubble up from a child view to a parent view, there also without explicitly passing a binding through an init. And I think that concludes this chapter on state management in SwiftUI. Thanks a lot for following it. Big thank you to the people watching the live that asked very good questions and made very good remarks in the chat. It made the live feel much more much more alive for me as I recorded it. But also these questions and remarks will have a lot of value for the majority of people that will be watching this as a replay. So thank you for sticking with me and for asking such great questions. As you can see, I'm starting to get a little bit tired. It's because in France it's starting to get close to 10:30 p.m. So I think it's more than time for me to finish this live. And so I will say see you in 1 or 2 weeks for the next live, which will be about how to deal with navigation inside a SwiftUI app inside the SwiftUI app. Enjoy your evening and the rest of your day. Thank you for watching, and see you next time. Bye bye.